Okay, quick check on your instances. Okay, so I will be doing some changes here. Let me make it highly available. You have three nodes, all right?
Yes.
Okay.
Mm-hmm. Yeah.
Okay, this is done. All right. Okay, so we will be starting with Hive today. I think we completed Yarn, or did we left with some part of it? Yeah, I think we completed Yarn in the previous class. And let's start with Hive. All right. Isa, can you do one more thing? Just
Yeah, sure. Go ahead.
okay, but it's on your laptop, right? This key. I'm looking for this B
Yeah.
key. Okay.
Oh
Okay, no issues.
no.
No issues. So what I can do is
Okay.
I can open the
I
heal.
think I do have the two key. Remember that I had an issue with the B9 PEM, and then we downloaded another one.
Uh-huh.
But well, that's everything in my laptop. I'm so
Yeah,
sorry for
it's
that.
in no problem. It's in your laptop, so we cannot open that. Okay, no issues. I can
Yeah.
do the same thing from you also. It's fine.
Okay.
The same password
Uh,
admin is used. Okay, for you also.
okay. I just have a quick question for you. It's not about the yarn. It's about the shell scripting that we did.
Mm-hmm.
That you gave us the video. So are we gonna go back to the shell scripting again?
I'm not sure. Did we left out
Like,
something in that?
no, no, no.
Yes,
I'm
I
just
think.
wondering because
Mm-hmm.
because you said like after practicing the script you
Yeah,
have
sure.
showed
So
that, and we're gonna be familiar with that, and then we will do that again. Is that what you meant, or
I
I'm
think
just
I think
thinking?
the basic part we have already covered of shell scripting in those two
Okay,
videos. But
okay.
if you want to go into more advanced stuff, so for that I must have told you that we can connect after we are done with all the classes, and then we can do some hacker rank questions also. I think that's what I can remember, right? So once you have
Oh,
done
I
with
think
that,
so. Yeah.
yes.
Okay.
So for the advanced
Gotcha.
stuff, we can go for another class maybe, and we can try out some hacker rank questions so that we become more familiar with that. So that's what I meant. So it's fine. Once we are done with all these topics, we can have one session for that.
Yeah, because I'm still on the I'm still on the shell scripting part. I'm still not practicing the yarn yet
Okay.
because I'm trying to memorize, not memorize, just to process the shell scripting part because I did know a little bit of Python,
Mm-hmm.
but I'm not familiar with the shell, but it's pretty much closer. But that's why I was just keep doing the shell, keep doing the shell. So maybe after that I will start yarn maybe a week later. Yeah.
Okay, no issues.
Okay.
Okay, guys. So the topic for today is Hive, and okay, so far, so we have discussed about HDFS. I told you that it's a storage layer. Then we discussed about Yarn. I told you it's the processing or the computing layer, computational layer. Now let's talk about Hive. Now this is also a computational, I can say, framework that works over Yarn itself. Okay, but the point here is that it creates a metadata to give structure to the HDFS data. Okay, so just like any traditional database like RDBMS or anything, we used to have tables over there. We used to store data into a tabular format, which had uh, rows and columns, and everything was pretty sorted up. Similarly, to give us same feeling, to give us same understanding over the HDFS or over the Hadoop layer as well, they created Hive. Okay, so what Hive does is it uses the same layer, both the HDFS and the Yarn. So HDFS for the storage one and Yarn for the computational, but it adds some more metadata over the already stored HDFS data, and this metadata contains the tabular information like columns and rows and stuff. So you are giving a structure to the unstructured data which is present in the HDFS by giving it some structure in terms of columns and rows. Okay, so it gives structure to the data stored in HDFS layer, and that structure is the tabular format. Okay, now if I would have logged into the shell, I could have shown you that we can actually launch Hive in two ways. One is just on the shell, you could have typed Hive. Okay. It will open up a prompt and you will enter the Hive shell. So whenever you are logged into your computers, just try to do that on your Cloudera Manager host or any other host. Just try to type Hive and press enter. You will enter a shell, which is a dedicated Hive shell, basically. Okay. Now, when we are talking of tables and tabular format in Hive, we need to understand what kind of tables and what kind of structures do we have. Okay, so we will start by creating a very simple table. We will create a table named, let's say, employee, which has two columns: name, age, three columns: salary. Okay, this is something extra that we have added to the format. This kind of thing is quite similar to how you create table in RDBMS or traditional databases. Okay, just by typing the table name, its column, these are the types. So the name should be of string type, age is of int means integer, and similar is with salary, it's also an integer type. Now we've added some to give some more formatting. So we have given the row format delimited. That means every row is having columns with a delimiter or some delimiter at the end, and every field is terminated by a comma. So all the how would Hive understand that this particular data belongs to a particular column? It should be separated by a comma. Okay. So we could have used this command and typed it on the Hive shell, and it would create us a table. But for now, I don't have a Hive shell, so I will do it the same thing from you. I think there has to be. Okay, let's create this. To run this command, I will have to click on this button, execute. Okay, so it has created the table employee for me. And the beauty of this hue is everything will start appearing on the UI. So the same things that you could have done from the shell, you can do it from here. So I will just refresh this. Now, one more thing to understand, whatever tables that you create, they has to have a database. Okay, database, it's a container which is like a collection of tables. By default, we have only one database, which is default. Okay, so a database is like it's a container of various tables, just like how you have in RDBMS. You know, there also we have databases and we have tables. So right now this table got created in this default database. By default, there is only one database called default, but we can create more databases. So to create a database, the command would be create database. Let's call it Hadoop B9. Now to just run this command, I will just select this and execute. Okay, so now we have another database created. If I would refresh it, yeah, this is Hadoop B9. Now this table actually got created in the default one. If you can see, it's here. But I want to create it in the Hadoop B9 database. So what we'll do is just before the table name, put the database. Okay. So look at this. Okay. Not run. Let me select this. All right. So this table is now created in the Hadoop B9 database. You can see it's present here. Okay. So far this all of this thing is what we have created is we are giving a structure to the data. We haven't yet placed any data into this table, right? So we have just created a metadata. So this Hadoop B9 database and this table, whatever things that we have created so far, it's just the structure. It is just the metadata. that I was talking about. So this is a metadata. Now let's quickly look at the instances that we have in Hive. Sorry, not in Hive, in Hive. To understand the structure, how everything is working in here. Okay, so we have this Hive Metastore. Now this is like the master. Okay, this is the service which is handling all this data or all this structure or all this metadata that we are calling. So every table that you create, every database that you create, every information like this about that table, this is being handled by Hive Metastore server. Okay. Uh, yeah. So I was talking about the architecture of Hive. So you can imagine that we have a layer of yarn and a layer of HDFS at the bottom. Now over this layer, we can have multiple Hive Metastore. Now why multiple? Sorry, we can have multiple Hive server. I will talk about Hive server. Okay, and okay, so far let's remove this layer because it's not connected to the Hive server actually. Okay, somehow, something like this is an architecture. So we have Hive Metastore, we have Hive servers. Right now you can see only one Hive server in here, but you can add two more because we have three servers, right? And then this Hive Metastore is connected to a backend relational database system. Relational database means it's the traditional databases which we have in like we have tables and rows. Okay, so if I just show you in the configurations, you will see that there is a backend database this Hive connects to. So in here right now, this Metastore, we also call it the backend Metastore database. So right now it's of a kind of Postgres. So these are all different kind of relational databases. Some of you might be familiar with MySQL, Oracle, right? So right now we are using an embedded environment. Embedded means this database is provided by the same installation that we did, and it's an embedded database. So we are using it of a kind as a Postgres SQL, and this is the server where the database is running. So right now it's running on the same server that we have Cloudera Manager on, and these are like the port of that server, user and other stuff. Okay, so this is the backend database the Hive Metastore will connect to, and this is the place where it's actually storing its metadata. So when you create this table, this information about the table, it's being stored in this backend database. Okay, only this metadata is being stored here. Now let's say I want to add some data to this table. Okay? If I would want to add some data, so let me add some data. There are two ways. Okay, you can either add it directly from the command line, or like directly as a insert statement, or you can load data as well from a file. Data from a location stored in HDFS. Okay, so we will be using right now a direct insert statement, and probably I'll also show you how you can load it from HDFS. Okay, so for direct insert statement, the command would be something like insert into table, followed by the table name, followed by values. Okay, we can add value. We can see it's actually launching a yarn job, a MapReduce job. This is the job that it launched. Okay, let's check it from the Yarn UI itself. Yeah, it's actually running a Yarn job, but it shows it's still in accepted state. It's not running properly, I think. Okay. Yeah, it's still in accepted state. So let me just kill this job. Yeah, I killed it. Somehow it was not working. So what I'll do is I will log in from HDFS. And in the meantime, I think we need to add a few more nodes. It only has one node manager. So I will first of all enable high availability. Okay. We need to add two more node managers. Hmm. I think those directories needs to be created. But okay, I think Asa just create those directories when you have access to the laptop. For the meantime, let me just try and run this with another user. I will add a user HDFS in view.
Uh, Sahil, for creating those directory, I need that B9, that
No, no,
B9 PEM?
it's a Linux directory. So when you log,
Okay,
just go to this node and go to the var
yeah.
log, go to this directory,
Hmm.
var log yarn. You will find something like a yarn uh, node manager dot log, something like that. Okay. In this file, when you
Okay,
open this file,
okay,
at the last line, it will tell you which directory is not present. Okay, so you can create the. I think the directory would be. I think it would be slash yarn
yeah,
slash and
okay,
something like that. Just check that. So you
okay,
create this directory on both the node managers and then start it. Okay.
okay. Hmm.
Uh, this is fine. So this is we are managing the permissions for the HDFS group that we created. I'm just picking right now the permissions I need to work with Hive tables. Okay, so now we will log in with Hive user, HDFS user. Okay, let's run those commands again. Okay, one more thing I was missing earlier. It's a string basically. It will again launch an application. Okay, it's again coming into accepted state. I think this is because of we only have one node running right now. The memory and the cores are probably not enough. Okay, but we should have 4 GB RAM, I think. Uh, yeah, 4 CPU and 16 GB RAM we should have, right? So let's increase this. Probably that's why it's not running. So whatever stuff that I'm doing right now, it's basically your admin's responsibility. Right now you can see that my job is not running. Okay. I see that okay, it's not
Yeah.
running because probably I don't have enough resources. I only have 1 GB RAM and 4 vCores. But I could have done two things. One is either I could have started these two nodes and that would have added up the resources. Otherwise, what
Hmm.
now I can do is I see that my node is basically of 16 GB and it has four. So vCores, I think, is try to increase RAM. This is basically a default one which is set. I will try to change. Yeah, it's appearing 1 GB. Let's make it 2 GB. Container yarn node manager resource memory. This is what I'm looking for. It's appearing 1 GB right now. I will make it 2 GB. It will ask for a restart. Yeah. Let's check this page again. Yeah, now it's coming 2 GB. Let's see if it works for us. Yeah, I think now it's running. Yeah. So the earlier the issue was with the memory of that one node. Yes. So now my data is added to the table. Yeah. The job is finished. Succeeded. All right. So the data is present in the table. Now how will I check the data? The command would be quite similar to how we would have done it in RDBMS. So I will do select star. Star means to show me all data from employee. Okay, so we have only one row with this value. Similarly, I can add more rows. Yeah, so I have added one more row to the same table. So now we have to, so you can keep on adding rows using such a command. And what you did understand it, that this is basically launching a Hive job, or sorry, no, a MapReduce job on Yarn, and this data is actually being stored in the HDFS layer. Now by default, for tables like these, okay, the location within the HDFS. Okay, so we saw that when we are loading data, it's launching a Yarn application which is of type MapReduce, and the data is stored in HDFS. Now for table like the ones that we created, the tables that we created by default, they are internal tables. Okay, so the tables that we created by default, they are called internal tables, and the location where this data is actually being stored is by default /user /hive /warehouse. Okay, now within it you have actually your database name, dot db, and then you have your table name, and then you will see that the data is stored there. So to quickly show you that also, I think we can check that from here also, I think. Yeah. So if I go to user Hive warehouse, you can see this is my DB name, Hadoop v9.db. This is my table name, and within it, this is the data that we stored. See, this is the value. If I just go to other file also, see. So this is by default the location where internal tables store the data. Now, what if I delete this table? Okay. What if I delete this table? Now, if I delete this table, definitely it will delete. Okay. So this is an internal table. If we delete an internal table, the associated data also deletes. Okay. To counter that fact, because sometimes it may happen that somebody mistakenly deletes a table, right? So let's say I mistakenly deleted this employee table. Sorry, it's not delete, it's drop. Okay, so once I delete this table, if I refresh it, uh, yeah, there is no more employee table present. If I run the statement, it says table not found. Okay, so this table, when I delete it, now to add on to this architecture some more points. Okay, so the actual data is basically being stored in the HDFS layer, and when you run a job, it's being copied using yarn. Okay, so that's what I want to mention by this architecture in here. Now, so the associated data also gets deleted from this, from the default location of the table. Okay, so this is the default location. The data gets deleted from this location also for an internal table. Okay, to counter this fact, what we can do is we can create a table of type external. So the same statement, So what is an external table? The location where data is stored is defined at the time of creating the table. Also, when we drop an external table, data doesn't get deleted. Okay. Just to make it more clearer, I will again show you that file is actually, both the files are actually deleted from the default location. You see, there is no employee table file which was earlier there. Okay, but now we will create the table as a type external. Okay, so same command, but we will create it as an external table now. So the syntax is a little different. So we will say create external table first of all. External table. This is a table name. Everything will remain same. No formatting with. But now we will add another thing called location. And let's say I give a location in /temp. Okay. So let's create this table. Yeah. So the table is created. Now, if I want to, sometimes let's say I don't have this create statement. Okay, let's see if this table is present. Yeah, so now the employee table is created. How will you understand that whether this table is of type internal or external? So what I can do is I can run this command, describe formatted, followed by the table name. So it will give me all the information. You can see the table type is external. Okay. And other are different application. You can also see the location. The location is in 10 in HDFS. Okay. Now let's again put in some data to this table. Yeah, so the data is now added. Let's see if this is present. Okay, let me see what is issue. I have to go to temp. Okay, maybe it's not picking up. What I will do is let me change the location to HDFS only. HDFS / table name. Let's use this location. Let's call it another table employee 2. table 2 is created. Let's check its description. Yeah, it's in user HDFS. Let me add some data into it. Yeah, so now we have a data field present. Let me also add another field. Yeah, so this is also added. Let's take a look. Yeah, so we have two data fields. If we check the location again, in the user HDFS, you can see this employee folder, and we have those two data fields present. Okay. Now I will again delete this table. Now what do you think? So it's an external table. I told you when you drop an external table, only the metadata gets deleted. So only this information about this external table, how many you know columns it has, only that will get deleted. The data doesn't get deleted, but only the metadata or what we call as a stable structure gets deleted. So even if somebody mistakenly deletes, so although this table is deleted now, I cannot get the information also because it says table not found. Okay, that is fine. But if I check a look at the location, the data is still there. See, the data is not deleted. So I can still recover my table back. How will I recover it? The data is not deleted. Okay, that is the main point. Somebody deleted the table, but the data in HDFS it's still not deleted. So to recover it back, what I can do is I can again create the same table or the metadata. So this is what I am creating is a metadata right now. So once I create it, it will still not show me the data. Okay, it has started showing up. But if somehow it doesn't shows because the data was already there, right? So I did not need to add it again. Data was already there. I just recreated the metadata, which is the table structure, and the data started showing up again. Somehow, if for some reason this data might still not appear, you can run this command msck repair table name. This will repair the metadata to pick up the data present in the external location. Okay, msck repair table. Yeah, this command will repair the table which was somehow there was a mismatch between the metadata and the data. Okay, so it's always recommended to create an external table. It's always recommended create an external table to prevent such to prevent data loss when mistakes happen. Okay, always make sure that, and you will see in your companies also, that all the tables are of type external. Now in the next class we will discuss about some more tables, basically two more type of tables. One is called a partition table and other one is called a bucketed table. So we will discuss about these two tables also. And in the meantime you can practice at your end also. But I see some of you have still not created the cluster, so please guys, take it seriously. Start, if you have practiced it, it's fine. If you have practiced it and deleted it, that is fine. But if you have still not practiced it, I think you should start doing it by now. Okay. All right. Any questions?
Yeah, Sahil, are we meeting next like coming Thursday, or we are meeting next Sunday?
Okay. So for the previous 2 weeks, I had some other priority task. I couldn't join session.
Okay.
Next Thursday, I will try my best. I will try to join next Thursday. But if anything, I will update you. Okay. So right now, I
Okay,
cannot
perfect.
tell you, but by Wednesday or
Okay.
Thursday, picture will be clearer and I can update you on the group itself. Okay.
Okay, no problem. Thank you.
Okay. Okay. That's, I think, no more questions. We can call it off. All right. Thank you for joining, guys. Good night.
No problem. Bye.